Okay, we are going to divide radicals today, or divide square roots. So the issue with division of square roots is we do not want radicals on the denominator. Now, the question is, why don't we want radicals on the denominator? And the answer comes into when I perform operations. It's easier to add and subtract fractions if they have the same denominator. And it's easier to get denominators of whole numbers or integers rather than radicals. It's also easier to make decimal approximations with radicals if your denominator is not a radical. So, for this instance, square root of 3 is 1.732. 1.7. It's hard to divide 2 by 1.7. That's not easy to kind of think about. But if it were not a radical in the denominator, so if I had this, can I take easily 1.7 and in my mind divide it by 2? A lot easier than going the other way, right? So that's why we do not want a square root on a denominator. So we're going to have to come up with a way to do that, to get rid of this square root on the denominator. Easiest way to do that is to think about it this way. Can anybody tell me what the square root of 3 times the square root of 3 is? 3. So the square root of 9, which turns into the square root of, which turns into 3. After we do that, the radical goes away, correct? So what I'm going to do is I'm going to take the denominator and multiply it by the square root of 3. But remember, what I do to the denominator, I've got to multiply the numerator by as well. What is the square root of 3 over 3? 1. So essentially I'm multiplying by 1. Just changing the look of it, not changing the value of that fraction. So what happens here is I'm going to have 2 square root of 3 over the square root of 9. And the square root of 9 is 3. So I'm going to have the same fraction being 2 square root of 3 over 3. It's the exact same value as 2 over the square root of 3. Questions? Next one is I'm going to have the square root of 6 over the square root of 15. Square root of 6 over 15, or the square root of 15, I'm going to do in 2 separate ways. First way I'm going to do is I'm just going to multiply by the square root of 15 over the square root of 15. That gives me the square root of 90 over the square root of 225. I know that that's going to be 225 is a perfect square for what? 15. And then I'm going to reduce the numerator. Square root of 9, square root of 10. So I have 3 square root of 10 over 15. What I can do now is I've got to reduce this fraction. Can I reduce that fraction here? Absolutely. So what I can do is I can reduce it here. So there I can divide by 3. That gives me 1 here and 5 here. I am not going to divide what's in the radical. I'm going to leave that alone. So my final answer for this one is going to be the square root of 10 over 5. All radicals are reduced, all fractions are reduced, and there's not a radical in the denominator. Yes?
Reduce that.
This?
Yeah.
That was the random. I'm just saying that I can reduce this fraction, so I can reduce that fraction. Now I am going to do this in a completely different way. I'm going to rewrite it again. Now, am I able to call the square root of 6 the square root of 3 times the square root of 2? Is that the same thing as square root of 6? Yep. Square root of 15, can I call that the square root of 3 square root of 5? Again, yeah. What I'm able to do now, because there is multiplication, I can cancel those out. And all I'm left with is the square root of 2 over the square root of 5. Once I multiply by the square root of 5 over the square root of 5, that is going to be the square root of 10 over the square root of 25, which is 5. Do we see how we get the same answer? Just a different way to think about it. I reduce the fraction first by canceling out radicals, then canceling out the numbers at the end. Either way you want to think about it. Questions? Here's the next one. What I'm going to do is I'm going to just multiply by the radical, not the number. You can do the number, however, that is going to make your life harder in the end because you will have to cancel out another 3. All it's going to do is make the fraction bigger for you to have to reduce it in the end. So when I multiply that across the top, I'm going to multiply 5 squared root of 2. That is going to be 3 squared root of 4. What's the square root of 4? 2. So my answer is going to be 5 square root of 2 over 6. Can I reduce that at all? No. I cannot reduce what's in the square root. I'm going to kind of explain this. Everybody sees that the square root of 2 is irrational, right? It can't be described as a number. Let's say, I'm going to guess this is the way you would try to cancel out within a radical. You would say, oh, this is 2, or that's 1, and this is 3, because I canceled out a 2. Do you see how that is 5/3 now? Square root of 1 is 1. Everybody agree? 5 times 1 is 5 over 3. Is 5/3 irrational? No, it's rational because I can describe it as one number over another. So those are by definition not equal. You cannot cancel out a radical when we're dealing with fractions. To reduce it, you can't cancel those out. So our final answer is 5 squared root of 2 over 6. And that's where we're going to leave it. Please try this one by yourself. You will have to reduce a fraction. So when I multiply that out, I'm going to multiply the square root of 2 over the square root of 2. That's the square root of 8, or 8 square root of 6 over the square root of 4, which is 8 square root of 6 over 2. That can cancel out. I'm going to be left with the 4 here, 1 here, so that answer is 4 square root of 6. Questions? Again, if there is a number and a radical on the bottom, all I'm going to do is multiply by the radical. Square root of 5 over the square root of 5. I'm going to have square root of 40 over 6 square root of 25. That's going to be 30 on the bottom, 6 times 5. And I could break the square root of 40 up into the square root of 4, square root of 10. So that is 2 square root of 10 over 30, which reduces to the square root of 10 over 15. Let's do this one. Now, we don't always, this is one that's going to probably be easier to cancel out a little bit before we do anything. So I'm going to write this a different way. Trying to make my life easier, okay? So do you see how I broke down into the 9, I kept it on the outside of a radical. The square root of 21, I broke it down into square root of 7, square root of 3. I did that specifically because I knew that there was a common factor of the square root of 3 in those radicals, right? So do you see how I can cancel those out? So now I have 9 square root of 7 over, I'm going to say 2 square root of 2. Because what I can do is I can break the square root of 8 up into the square root of 4 square root of 2. That is 2 square root of 2. So I'm always thinking if I can reduce a radical or reduce a fraction. Just trying to break it down into smaller things so it doesn't, I don't have the square root of like 8,400. That's going to be hard to reduce. It's going to take you more time. I'm going to try to break it down if I see those factors. Then what I'm going to do is I'm going to multiply by the square root of 2 to rationalize. Two times square root of 4 is 4. Because do you see how if I started out at the beginning, I'm going to have 9 square root of 504, and then I'm going to have to continue to break down 504, and then I'm going to have to reduce the fraction as well. It's just breaking it up into easier parts, more manageable parts. Questions? All right, as some of you are about to go to sleep, we're going to step it up just a notch. What's the big difference between this one and the ones we've been doing before? There's a plus. There's addition in the middle of the top. So we have a binomial on the top and a monomial on the bottom. Any ideas of what we're going to do? we're going to have to do the box method, right? And this is only going to be a 1 by 2 box, because what we can do is still multiply by that square root of 6 over the square root of 6. On the bottom, that's going to give me the square root of 36, which is just 6. However, on the top, we have got to be able, we're going to have to distribute that. So either I'm going to distribute it, or I'm going to do the box method. Where did I get that square root of 6? Never mind. 5 squared. Plus 5. Is that my final answer? Well, is that my final answer? No. Why is that not my final answer?
You can simplify 18.
I can reduce the square root of 18, square root of 9, square root of 2. So that's 15 square root of 2. Now, can I take a 3 out of those? No. I can take a 3 out of this, but in order to cancel it, I'm going to need to take a 3 out of that. Can I take a 3 out of 5 square root of 6? No. So nothing's going to cancel, so I'm just going to leave it. I think we have some drifters. I'm seeing one of these. Do we need to stand up, get a cup of coffee, have a chat, or just power through and fall asleep at the wheel? That's always a good option driving, right? All right, here's the next one. Yes! Now I do have the square root of 12 there. What can I do with the square root of 12? Reduce it. I'm going to reduce it as quickly as possible so my numbers don't get really big. That's going to be 12 square root of 3. What do we notice about the numbers, the coefficients of those numbers? They are all, they're both all divisible by 2. So what I'm going to do is I'm going to factor a 2 out and then cancel it. Cancel, cancel. Any questions on that? I still have to rationalize it. Multiply by the square root of 3 over the square root of 3. I'm going to get 2 square root of 3 plus the square root of 45 all over 18. Final answer? No. You mean I've done all this work for just that? Absolutely! Why aren't you guys excited as I am?
Where'd you get the 15 from?
I don't know. It was 5. Then this becomes just a 15. I was thinking that was weird from the problem before. Can I reduce the square root of 15 now? No. So that's my final answer. Darn. I kind of wish I had to reduce another radical. Kind of disappointing. Good things there's another slide for you guys to do it. Please do that by yourself. This is the last slide. And then you don't have to hear me talk anymore. I am thinking a quiz for you on Monday. I am not going to be here on Friday. I am going to be at school, but we are going to a math competition at OSUM. So I'm going to be working, but not here. So I'm going to leave a review for you and then a quiz on Monday. All right, first thing I'm going to do is I'm going to reduce that radical. Square root of 4, square root of 6, so that's 12 square root of 6. Then I'm going to multiply by the square root of 6 over the square root of 6 to rationalize. That's negative 2 square root of 6 plus the square root of 12 all over 12 times 6, which is 72. Next thing I'm going to do is I'm going to reduce the square root of 12. That's going to be negative 2 square root of 6. Square root of 4 square root of 3, so 2 square root of 3 over 12. Actually, that's a 72. Last step, I'm going to see that all of those coefficients are even. So I can pull out GCF of at least a 2 out of there. So that is going to be 2 times negative square root of 6 plus the square root of 3 over 2 times 36. Those can cancel. So my final answer is negative square root of 6 plus the square root of 3 all over 36. Question.